Okay, so we were discussing about the solution of the wave equation on an infinitely long string and with initial conditions. Now let's see for how does it look like, means with some example maybe, so that it will be much clearer. Say you have this string and let's say you have started it with this initial condition. Okay. So this orange part is the deformation basically. So this green is the undeformed shape and this orange you think to be the deformed one to start with, and then you left it. So what will happen? So let's see our what does it tell? So now we are talking about this only. Okay, this is not there. So that means this part of the solution. So let's see what it means. So you can think that half of this maybe it looks something like this, right? This is not exactly half, but yeah, assume that this height is half of this. Now, so this is at say t is equal to 0, right? Then if you go to say some t equal to t prime maybe, or 1 second, just assume that after 1 second, what happens is one of these waves. So now you just think that there are two waves sitting here. Let me also maybe draw that. So one is with purple, the other one is with blue. So there are two waves sitting there, half weighted. Now let's say the purple one starts moving rightwards. Then what will happen? After some time, so this one will be like this, and this blue one will move like this. Why did I do that? Because I am thinking about some other thing, the reflection. I was thinking about the reflection because that's the next topic. Anyways, yeah. So this one will be like this. Okay. So that means if I draw the right? So this will be the shape of the string after some time, right? And yeah, so then so this may be at say t is equal to 1 second, say, okay, depending on the speed and all. Then if I draw the third one, maybe it will be completely maybe they have passed like that, and this one has moved like this. Okay, so yeah, so that's the setup. Okay, so this part moves this way, this part moves this way. So here I can draw that this part moves this way, this part moves this way. Now if I tell, so here I'll just for completeness, maybe it is at say 2 seconds. So that's the meaning of the whole thing. Now if I tell you the same thing you should do for a velocity profile. Okay. Suppose you have a string like that, and on certain zone you have, say, I'll say the velocity is a constant over this. So I have given a constant velocity profile over a certain length. So what will happen? Sure, 1 minute. The signs are proper, no? Yeah. So what do you think will happen? See, you just correlate with this now. We have now only this condition, not the upper one. We have got only the velocity. So first step is we have to integrate it. The shape, which is a constant, if we integrate, you will get a inclined line with some slope, right? So now if that slope is say like this, so that is my SZ, but half of that will be going forward and half of that will be moving forward with that division of C and everything, not half, 1 by 2C and 1 by 2C, okay, in this side and that side. And but then you just think about one more thing here, this part. Here both were positive. Here the rightward wave is negative. Okay, so that means when you come here, you will have two parts. Say one part is 1 by 2C I am drawing now. Suppose this is 1 by 2C times that S, and similarly minus of that will be in this direction, right? Sorry. So these are those two parts, right? So I'll write it here. This purple one is minus 1 by 2C times S of x minus Ct. No. Plus, right? So this is plus, yeah. And this one is minus 1 by 2C S x minus Ct. Now they will start moving with respect to their own directions. So this one will move this way. So this one will move this way and this one will move this way. Okay. Now what will happen? So after some time maybe, so you can have something like this. And the other part is right. So then the combination is so from here it will what will happen here? Not here, no, sorry, up to this point it will go, after here it will start decreasing, but as soon as this point comes it will be 0, right? and then it just, you can plot the other things. So that is the meaning of when we said, or it's a geometric representation of what we saw here algebraically. Okay. So that means now you should write a code as an assignment which should take a function, given any function of initial conditions of displacement or velocity. With that given condition, you should be able to plot how with time, and then the speed c, we should be able to animate how the wave will propagate on the string. Okay. Okay, so that's one part, and yeah, we'll stop here for this segment, and again we will meet.